Storm and Sanitary analysis. Well, when it comes to doing storm sewer analysis or design, our options in Land Desktop are both severely limited and severely outdated. So just to see a quick example of that, let's go ahead and create a new project here. We'll set up one, we'll call it Project Pipes. And we'll create a new file called Storm Sewer, because for me to be able to access any of that functionality, I'm going to have a drawing that is associated with a Land Desktop project. So we'll just go ahead and create a new project, new point database, and we're in. Now the first thing, that functionality was not available historically in just plain Land Desktop. We had to have the Civil Design module installed. That gave us access to those tools. So in Land Desktop Companion, and right now I'm running Land Desktop Companion 2009, I'm also going to be running, when we flip over, Civil 3D 2012. So as we compare and contrast between them, those are the versions of software that we're working with. In Land Desktop Companion, it's shipped with Civil Design and Survey modules, and we can control which one we're working with by leveraging the workspaces in Land Desktop. Now with the Civil Design workspace available, we've got a hydrology pull down. We've also got a pipes pull down that we can work with. Hydrology is where we would start getting into some information. We've got culvert calculators. We can start computing rainfall. We've got the TR55 method of calculation. We can deal with some HEC2 output. If we come over into pipes, we can build, and this was a limitation in Land Desktop, is we can only build things in the concept of what's called a run. In other words, from downstream to upstream, we've got a single run. Any laterals coming in from the side, we would have to find a way to handle those manually. So at the end of the day, Land Desktop did not deal with an entire pipe network, but only just continuous runs within our project. So as it relates to pipes and hydrology, a lot of people would historically use Land Desktop, the pipes functionality, to display their pipes in a profile, maybe do some annotation. That was certainly faster than creating it manually, but from the design perspective, actually coming in and doing calculation and stuff like that, not so much. And the reason I say that is because the tools are, as I mentioned before, fairly outdated, as well as also fairly limited. Another thing, and this will tell us everything we need to know, if I were to click the button to do a culvert calculation, the dialog comes up and tells me that the output should be verified before use in final design. So that pretty much tells me everything I need to know, that as it relates to a design tool, this was more for planning in the planning stages than it was for actually doing detailed design for our project. So with that being said, I'm not going to necessarily worry about or work with that the tools within Land Desktop. We will instead move to Civil 3D, where we've got a far more robust set of tools with which to do storm analysis and storm design. And in addition, we can also do sanitary analysis, which was not possible at all in Land Desktop. Now, the first thing, when we're in Civil 3D, we'll take a look at, we saw a culvert calculator. We'll see that if we look on the Analysis tab, if we expand the design area here and we launch Express, you'll see that there's an Express extension, that we've got tools that we can compute data or information with respect to culverts, channels, various inlets. We can create a hydrograph, weirs, and more. And as you start drilling down into these things, like with respect to channels, you can have a standard rectangular channel, you can have a V-bottom or a triangle section, all the way to a user-defined or custom channel. So we can plug in our numbers, run our values, and we're ready to go. So with respect to that, if those were some things that you leveraged on the Land Desktop side, we've got full access to those tools directly within Civil 3D. Now, some other things that we have in Civil 3D is we have the ability that we can harvest or pull directly from the model values that can populate the different dialogues within our analysis package. And what I mean by that is rather than historically, both in Land Desktop and many of the other applications that are out there, instead of performing a computation for a catchment area, determining what that area is, and then having to manually type it into the design, run the design, and then take the results of pipe sizes and other things, keep manually moving numbers back and forth, we can continue to work on that interactively in the model. So from a Land Desktop perspective, if I would like to use Civil 3D as a tool, it is a phenomenal tool for doing our storm and sanitary analysis. We may not directly work on the Land Desktop aspect or the drawings themselves. Certainly we could load some of that into Civil 3D and work with it. However, we also have the ability, we could open that environment and work just in a straight analysis type of a spreadsheet application. So let's take a look at this. First thing, let's take a look at that application. If I go to Start, we'll go to All Programs, and what's installed with Civil 3D 2012 and also Map 3D 2012 is what's called a Storm and Sanitary Analysis tool. So we'll go ahead and launch that. I can run it externally from Civil 3D, so I don't have to have Civil 3D running at the same time, but right now I happen to have it up. Once I come into the package, we can create such things as junctions. We can create a sub-basin or a catchment area. We can create outfalls, diversion, so we can break up things and separate the direction and the locations that they're going to go. We can create inlets and then storage nodes and then links in between them, pumps. The software supports a number of different components. We can go ahead and create those things schematically to perform our design. We also see some of this information on the side here as well. One of the things that the SSA extension or the package gets into is also water quality. So if we were to create some things, I can drop a junction onto the screen. If we were to double click on the junction, we can begin to populate information with respect to what the structure number is, invert maximum rim, surcharge elevation. We can start to populate all the different parameters that we would want for that particular structure. We could add another structure on the screen, and then we can start to connect links in between them. With that being said, we can just double click on the conveyance link, and then I can start to populate information about that. We can tell it the shape of the particular pipe. We can start telling it data as far as its length if we're doing it schematically, Manning's information, flow properties, all types of data. We can say from where it's going and to where it's going. All right, very straightforward, very easy to use. And then if perhaps I was going to route this into a pond, I could have my storage node and we could route it from this structure into my storage. So we can double click on that, and then we've got properties to define that as well. All right, so very straightforward, very easy to use from a schematic perspective. In many cases, this is what a lot of people would like to use. They don't even necessarily need to be in the CAD package to be successful with this. However, as we're going to look at it, since we're going to go through the recording, let's take a look at some of the advantages of working with or doing some of that design in Civil 3D such that I can move those values back and forth between the model environment and our analysis environment. So I'm going to go ahead and close the SSA application. Don't worry about saving the changes in there. And the first thing that I want to take a look at, we'll open a file here. I just want to look at a surface. This is a surface that was created in Civil 3D. And if we select the surface itself, we can start to do some things, water drop, to where I can click, and if a drop of rain falls on the surface, that is the low point at which it's going to reach the bottom. So Land Desktop had something similar to that. We could perform some analysis on the surface, but what's nice in Civil 3D is I can kind of do the inverse of that. If this was part of my design and I want to find out all of the area that was tributary to that particular low point, we could create what's called a catchment area. So I'm going to go ahead and we will come up and create a catchment. As a matter of fact, we'll just do it right from the surface here. So we've got a single catchment area that'll just give us an outline. So we'll pick at the bottom. It shows us the catchment area that is tributary to that particular point. From there, I could calculate an area and then type that into my other application if I wanted to. Historically, that is the route that we would have gone in the past. However, if we're working with Civil 3D 2012, we have the ability to create an even better catchment area. I'm going to go to the Analysis tab, and we'll come under Catchments, and I'm going to go ahead and create a catchment from a surface. Now, what will be different about this is instead of just determining the catchment boundary, it's also going to start to take a stab for me as the generating a flow path that I can start to determine my time of concentration. So we'll come in and click on my low point in my surface. It gives me some other values that I can fill in for how it will be displayed. So we'll just leave it catchment. We'll give it a name. We'll add some flow data by default. We'll let it take a stab at that. We'll click on OK, and it determines my catchment area. So once again, it is a catchment object. It has some intelligence in that it has a flow path that's been determined for us. So we see the furthest point. Using that length, we can start to determine time of concentration and things like that. By default, it's just giving me a value, a length, 976 feet, and it's got a slope. If we were to select the flow path using the contextual ribbon, I could come in and we could start doing some editing or reviewing the values that have been associated with that. So in this case, let's just go directly from the path. I'm going to right click and we will edit the flow segments. And right now you see that it's broken into just a single one here for concentrated flow for the whole run. I could add an additional one here, type in a value or select a point off the screen. We see that added, and then maybe the first section is going to be sheet flow. The second section after that is going to be shallow concentrated flow, and then based on what we put in for these values, we can start to control surface type, the Manning's roughness, cross-sectional value, wetted perimeter, all depending on what we go with. All right, so at the end of the day, its intent is to compute or help assist us in the computation of a time of concentration. Now, we have the ability to still generate the catchment area without the flow path if we're going to determine that later, or via another means, maybe define it manually. We can set that up as well. So with that created, knowing that we can create some catchment areas, the next thing I'd like to take a look at is perhaps a file that we can maybe have some of these things set up for us. Let me go ahead and open this up. Now, once again, this file here, I've got some storm sewer already set up. It's Civil 3D Storm Sewer. I do have the ability that I could drill down into Land Desktop and I could start to migrate forward some pipe data. Now, I don't have a tutorial project that has pipes in it that we can grab, and if I were to do that, I would have to determine obviously the catchment areas in that myself because those didn't exist in land. So, but here's the pipe runs area that we could pull those forward and begin to leverage that from an existing Land Desktop job. So in this case, just for the sake of time, I've already got my structures created, the pipes set up between them, and then I've got my catchment areas defined so that I can see what's tributary to each structure. So with that, the first thing that I want to do is I want to start to look at the profile perhaps so I can see exactly what I'm working with here. So to do that, I'm going to start by selecting up at the top here at Structure 1, and we're going to create an alignment from the pipe network. So we'll use the contextual ribbon. To do that, I'm going to come down to the bottom and we'll select at the outlet structure here to define from where and to where we're going to go. And let's see, we'll leave the standard name. As far as labeling, I'm not going to worry about annotating the labels for my alignment. So we'll go ahead and create that. And as far as data, it's going to show my alignment. The purpose is generating my pipes, but I'm going to cut through some surfaces here. The surfaces that I would like to see as part of my design. If we were to back up, there's a number of surfaces in here. We'll go ahead and add that it cuts through the existing ground, the finished ground composite, and then also the pond area that I have set up at the southernmost point of the project. So we'll select that and we'll go ahead and draw that in the profile view. Won't worry about any of the settings. We'll just take the defaults for right now. And if I pick up near the top, we see my structures and how it interacts with the existing. Certainly much faster than what the same process would have taken us to construct Inland Desktop. Now, with that being said, I want to get a little more information about what I have here. Specifically, I'd like to see some of this annotated. So I'm going to grab my structure. We'll come up to add labels here, and we will label the entire network profile. So all of my annotation for both my structures and my pipes have been established. Let's come down here near the bottom. In areas like down here around structure 12, I can start to pull some of these off to the side so I can see I've got 15-inch RCP as far as what's been set up for my storm sewer. So we'll pull some of those off to the side, 15-inch, and for this pipe, 15-inch as well. So it looks as though some defaults were put in, and then from here we can push this out and start to perform some analysis. So to do that, to be able to take advantage or leverage the model itself rather than going to each structure, determining its rim, the base invert or sump, and then coming to the pipes, determining the lengths and reconstructing all of that, we can grab one pipe that makes up our network, and we can come up at the top and we can edit that in the edit in SSA, so Storm and Sanitary Analysis. So we'll select that. It's going to give us access or bring into the application the storm sewer within our model. So we'll go ahead and select that, and it launches the application we looked at a second ago. Now it's going to do a couple of things as it comes in. First thing, it's going to give us the opportunity to create a new project, so that's fine. We'll go ahead and do that. The next thing is that data comes forward. It's also going to give us the ability to create a log file, or actually the log file will be created anyway. It'll give us the opportunity to save the log file so we can review that and see what data has come across. Now when the information comes in, it's going to not only give me the schematic, if you will, about the inlets and linkages or the pipes between the inlets and my outfall or my subbasin and that. It's also going to bring in for me the background drawing that I can see exactly where I'm at. So it's automatically brought that in. You want to save the log file. No, I'm not worried about that. We'll click over to Plan View, and let's pan, and we'll zoom up on our project. All right. So as we zoom and look at this, we see that it is loaded for us in the background the Civil 3D file we were working with. It's automatically, if we hover over a particular inlet and I double click on that, it has taken directly from the model all of the values necessary to populate that particular structure. And as I work my way down, you can see down here in the bottom all of the structures that have been brought across. So all the numbering, everything that's been set up in Civil 3D is automatically been set up here. The same holds true for my subbasin or my catchment areas. Those values have been brought across as well, as have the values for my pipes and for my inverts. Now, a couple things that the software is going to do for us, because these are inlets. I've got some different things that I can set up. I've got an outfall and I've got a bypass link for my represent my gutter. So any water that comes across the inlet that doesn't pass into the inlet and instead continues to move on down the gutter towards the next one, we can have what's called a bypass link to determine or calculate and take into consideration that flow with respect to how much is there and exactly where it's going to go. So it's automatically set up for us additional links that we can start to determine or create those bypass situations. Now, the first thing, in looking at my design, there was two structures that I was working with that were set up that they weren't going to be a standard inlet. We'll go ahead and open this up. They're not going to be just a standard on-grade inlet, but instead they're going to be set up in a sag. So those were actually structure number 2 and structure number 13. So we'll come down and set those. So there is structure number 2. That is going to be on a sag. And structure number 13 will be on a sag as well. So we'll go ahead and define those two particular types. we'll close out of that. Now this happens to be structure 2, much like in Civil 3D. If I hover over the particular structure, I get a tooltip that identifies that for me. As a result, I'm not going to need the outfall or the linkage or the bypass, so we'll go ahead and remove that. I'll come down and do the same thing for structure 13, which is also in a sag situation. Now, on the as far as the bypass link, basically this is where I would set up that any water that travels through the gutter for inlet structure 1 that isn't captured at that structure is going to be passed on to structure 2. For me to do that, I could click on the bypass link, or what is going to be my bypass link, and I'm going to come down and we will set a value for that. From inlet structure 1, it is going to bypass and go to structure number 2. And the ID for that particular pipe we'll say is going to be gutter from structure 1 to structure number 2. Alright, so with that being said, it's open channel because it's going to be running along my gutter. We'll go ahead and close that. The link has been added. I can right click on that particular link. I'll go ahead and edit the vertices. We'll add a vertex, and I'm going to click on that link, and we'll just pull it off to the side just so that it's a little bit easier for us to see that the pipe is going to take and pass through here, and then the gutter or anything that's going to bypass the inlet is going to work its way down to the second one. In doing so, I'm not going to need that outfall anymore, so we'll go ahead and eliminate that as well. Okay, so what I would do next is I would go through and I would perform this, looking at my design. I would basically dictate within the system how I intend this to function, rather than spending the time to walk through each one of these. I'm going to go ahead instead and we'll open up a section where that's already been completed. So we'll go ahead and open. I'm not going to worry about saving changes to that one. We will open up the version where that's already been established for me. Now when this comes up, essentially the only thing that's been done is the bypass links for the gutter have been created, and pretty much that's all that's been revised. So once that's set and comes into the into focus here, we will go ahead and zoom in on that, see our project. We'll see once again our CAD file represented in the background. So here is our file. Once again, you see all the outfall structures have been removed, and we now have bypass or conveyance links as it works its way around. So let's go ahead and start to analyze this a little bit. So we're going to go ahead and create a profile plot of our system. So we're going to go ahead and come down to the outfall structure. We're going to right click on that, and we're going to create a profile plot. And if we come over here on the side, it's basically telling us where to start, and we're going to go ahead and connect in the system all the different areas we're going to analyze. We want to make sure that we'll select the pipes. So we'll work our way up through here. This actually comes down to a junction. We just want to make sure that we're selecting the actual pipes itself and not the gutters or the bypasses. So we can specify exactly what we would like to see in our profile. We'll select the last one here. So with that selected, we'll go ahead and say show plot, and the extension shows us on the screen our design. We actually see that I happen to catch a gutter, so that's not going to work for me. We'll come back to plan view. We will set that up one more time. So we'll go ahead and select the outfall structure. We will start the profile plot, and we'll start working our way upstream. Okay, that's the fantastic part about this being as visual as it is, because in its fact that it's visual, we can that's the conveyance link gutter, so that's not the one we want. We want the pipe here. So I think that's where conveyance link pipe. That's probably where I had the issue before. So pipe, pipe, and we'll work our way across. All right, much better. Let's show that plot. Okay, much better. When we look at that now, we see that that graphically there is all of the pipes that make up our storm sewer in our plan view. So with that, we want to go ahead next and take a look at a water surface elevation for our pond at our outfall. So we'll go ahead. I'm going to double click on the outfall structure. I can do this both in plan view or in profile view, and I can start to set some values for that. I'm going to set this to a fixed situation, and I'm going to set my outfall water elevation to be 118. And I'm going to go ahead and close out of there. From there, let's go ahead and set up some of our project options. So I'll double click on that in my very similar to the prospector or the tool space. So we'll select that value so we can go ahead and get those. So within here we can establish our units. I'm calculating cubic feet per second. I can set up the type of what we're going to use for time of concentration method. So we'll set that up to SCS TR55. I'm going to come down, and the link routing method I'm going to use hydrodynamic. And we'll set my minimum conduit slope at 0.01. And I'm not going to worry about any as part of my system. So we'll go ahead and set this to none. And let's uncheck those guys. So let's go ahead and run that. So I've got some of my values set up for the project. The next thing I want to do is establish some of my analysis options. So we'll go ahead and select those. From within the analysis options, I'm going to set up my length of my storm. And in this case, we'll set up my storm to go from 9.2 to 9.3 at basically midnight. So it's a 24-hour storm or a one-day event. We'll go ahead and come over to storm selection, and I'm going to set this to 25-year event. All right, so I've got that established. The next thing that I want to set is I want to set up my IDF curve. If we open that up, we can very easily come in and create a custom curve, or the other thing that I can do is load something that's predefined. I'm going to load just a default IDF curve to work with. We'll go ahead and load that. And at this point, I'm ready to perform my analysis. So we'll come up and click on the little running man to perform that analysis, and we'll see the results within our system. So once that's done, I have some information about continuity and water quality. If we were running that, obviously it's not applicable at this point. We'll go ahead and say OK. And I'm going to come up to my output, and let's take a look at an animation of that. And we'll go ahead and play that back. So as we play that back, we can actually see the effects of the event within our system. So as the rain begins to fall and as it begins to enter in to the storm sewer that we've designed, we can see not only the water in the pipe at that particular point in time, we can also see a hydraulic grade line, as well as I can see little blue lines at each of my structures to show the maximum elevation at any particular structure. Now what's interesting about that is we can see that some of these are likely surcharging. So if we were to flip over to plan view, I could see from those particular structures, it's going to be down near the outfall, anything that's flowing at full capacity will be red, and anything that's surcharging, the inlets will automatically turn blue to identify that for us. So from there, we could actually come back in and start making some changes to this. Perhaps we'll change pipe number 14. If we open it up, it automatically highlights or identifies for us in red those things that would indicate that there was a problem. In this case, it was 18 inches. Let's take and set that instead to maybe a 24-inch pipe. We'll do the same thing, working our way backwards from 14 We'll go back to 13, do the same thing. We'll go back to 12 and 11. We'll just do something simple for right now. That's at 15. It didn't surcharge. We'll bump that one up to maybe 18. Oops, 28 might be a little too big. So go ahead and close out of that. Let's come back to our profile plot, and we will reperform our analysis, and we'll see what we get. So analysis is complete. We'll come down, we'll run a new output animation, and we'll hit play. Alright, now we still may, in this case, have some pipes highlight that they are running at full capacity, so they may still be highlighted in red. However, the blue lines, it does not look as though we are having any structures surcharging at this point. Maybe we'll have one that's pretty close. Let's flip over to plan view. And we can see that I've got pipes running at full capacity, but I do not have any surcharging at this point. So from here we can come back and iteratively make changes to our particular design and find the best mix of both structures, pipes, overflows, elevations to successfully convey the stormwater through my project. So with that being said, once my system is established and set up and I'm happy with that, what I'm going to do is I'd like to export this and bring it back into Civil 3D. So we'll go ahead and export this as a storm sewer file. We'll throw this out on my desktop and we'll just call this site plan project. We'll save that. And if we come back into successfully exported, oops, we'll come back into Civil 3D. And looking at the area that we were in before, we'll go ahead and we'll bring that back in. So we'll come down, select a pipe from our system, and I'm going to come down and we will import a storm sewer file. So we'll import, I'm going to come down into my list, site plan project, we'll say open. It detects I've already got something in Civil 3D. We'll go ahead and update the existing network, and what we should see is upon completion it go from 15-inch RCP up to 24-inch. Alright, so we should see our system automatically update. And we do. So here are our structures, our annotation for our structures. We see those have updated now to reflect the changes that we've made in our design. So the big advantage within a Civil 3D and an SSA extension is several-fold, and we could spend all day going through all the various things that we can do. But what's important to know is we've got a complete, robust set of storm and sanitary analysis tools that are available to us that we can either run externally without Civil 3D to perform analysis and design, both for storm and sanitary. We could also run it within Civil 3D such that if we were to migrate data over from Land Desktop, maybe as the basis to begin our design, we could start to add things like our catchment areas and flow lines to determine time of concentration, pass that directly from our model to that environment, make changes to establish our design, and then migrate that directly back into Civil 3D, which thus updates our system, all of our graphics, as well as our annotation. So if it's something that you've not worked with before and you've got Civil 3D on the shelf, and you've been doing your hydrology with Land Desktop or a spreadsheet or some other application, I would strongly encourage you to take Civil 3D out of the box and have a look at it. There is likely a tool already in your office that is very powerful and something you might not even realize that you already had. So with that, that completes this presentation.